So I've been asked by my wife to build flickering candles for this birthday cake for a play she's working on. I had multiple ideas that maybe I could use Arduino, but that's like $30, and then I'm asking non-techie people to help maintain this thing. There's issues of the embedded microcontroller and all the parts list and trying to get this done on time. And I was like, well, there has to be a simpler way. Well, it turns out that through the wonders of flickering tea light candles and doing some research on the internet, the modern flickering tea candles, they don't even have a chip anymore. There's a little thing built right into them that will cause them to flicker, and it's really not that noticeable with this guy. It's probably due to the IR it's putting out. It's probably overwhelming the sensor, but if you kind of watch, you can see it flicker a little bit. So the thing there then is, as it's flickering, a variable amount of current, of course, is going through it. And so doing some research, I'm like, oh, I need a transistor. Now, I'd never worked with transistors before, so I had to go out and get me some transistors and some resistors and some other stuff. And I found a whole slew of complicated circuits and how to make, random noise emitters and trying to reverse bias a Zener diode, and I just didn't want to filter it. So, I got the flickering LED, and I have set it up here. This is my lab bench power supply made out of an old ATX power supply, and so this one here is a 3-volt rail, and then there is a couple of 2N222 transistors arranged in a Darlington Pair, and the LED is going from the 3-volt rail into the input for the Darlington Pair, which I made by hand, and there is another resistor that basically sucks some of the current from this away back to ground. And I discovered that by changing the magnitude of this resistor, the flickering of these lights varies. Now these are 12-volt grain of wheat lamps, and I chose them because they're bright and they have a very nice, incandescent look to them. I could use LEDs, and so I wouldn't have to worry about having a 3-volt rail, and this here is 12-volt to drive these lamps. But I didn't necessarily think that the LEDs would look particularly like a candle when they're going. So I have a flickering LED here running at 3 volts. Part of the current is being drawn off to ground. I discovered that changing the value of this resistor controls the magnitude of the flickering. The lower the value here, the more the current's drawn off, and the more flickery these seems to get. This right now is a 4.7 kilo ohm, but 10 might work as well, and or 10 does work as well. So let me go and turn my lamp off here so we can see. Alright, lamp is turned off, and I turn on my power supply, and if you watch, you can see the LED flicker and you can see the lamps flicker. And I think that's pretty spiffy. I spent about a couple of days trying to get these darn transistors arranged, and I'm going to have probably each one of these guys drive a set of lamps, and I have several sets so that although some of the lights are obviously synchronized, I can sit there and mix them up on top of the cake so that you won't see giant blocks of synchronized lights. They'll be all mixed together, and they'll give a kind of a twinkling effect. So yeah, using a cheap, you can get these candles with the flicker LED at Joann's. They are 2 for $2.49. I just scavenge out the LEDs. That's what's going on there. And then hook them up and wire them to a little little hand-built Darlington Pair amplifier. Let me see. Yeah, they're not even getting, well, one's a little warm, but I think he'll be okay. Oh, and if it's not okay, it's a 10-cent part. You just take the eventual board, and solder a new one in if he eventually wears out. But he's only just a little warm to the touch, so I think he'll be fine. But it's, there you are, how to use a flickering LED from a cheap flickering tea light and have it drive some 12 volt incandescent green of wheat lamps. It's pretty slick.